In the previous lectures, we discussed the Big M method to solve a linear programming problem which involving some artificial variables. In the present lecture, we discussed the procedure for a two-phase method to solve the linear programming problems. Two-phase simplex method is another method to solve a given linear programming problem which involving some artificial variables. In the two-phase simplex method, the solution is obtained in two phases. First phase, we are eliminating the artificial variables. In the second phase, we are obtaining the optimal solution. Next, we have to look for the procedure for a phase 1. In this phase, we construct an auxiliary linear programming problem. For this, step 1 is assign a cost -1 to each artificial variable and assign a cost is 0 to all the other variables and get a new objective function is maximum z star equal to minus a1 minus a2 minus a3 etc. For example, we are modifying the objective function, that is the maximum z star equal to 0x1 plus 0x2 plus 0s1 plus 0s2 minus a1 and minus a2. So here we are assigning the cost value is the 0 for the basic variables and the surplus variables and also slack variables. And also we are assigning the cost value is the -1 for the artificial variables. Step 2 is write down the auxiliary linear programming problem in which the new objective function is to be maximized subject to the given set of constraints. Third step is solve the auxiliary linear programming problem by applying the simplex method until the either of the following three cases arises. First case is if the maximum z star is less than 0 and at least one artificial variable appears in the optimum basic at positive level. Second case is maximum z star equal to 0 and at least one artificial variable appears in the optimum basis at 0 level. Third case is maximum z star equal to 0 and no artificial variables appears in the optimum basis. So after forming the auxiliary LPP, then we have to apply the simplex method and we have to solve by applying the simplex method. Then we have to observe. So any following cases are present. First case is maximum z star, that is the new objective function is less than 0 and one artificial variables appears in the basis. Second condition is maximum z star value is the 0 but at least one artificial variables appears in the basis but its value is the 0. Third condition is maximum z star equal to 0 but no artificial variables appears in the basis. So in above the three cases, in the case 1, given LPP does not possess any feasible solution. Whereas in the case 2 and case 3, we will get the feasible solution. For this, I have to go for the phase 2. Let's see the phase 2. In the phase 2, use the optimum basic feasible solution of phase 1 as a starting solution for the original LPP. So in the phase 2, we have to start with the final simplex table in the phase 1. Next, we have to assign the actual cost to the variables in the objective function and a zero cost to every artificial variables in the basis at zero level. So initially we are assigning the cost values is the -1 and 0 for the artificial variables and other variables. Now we have to change. We have to assign the actual cost to the all the variables and 0 for the artificial variable. Next, third step is delete the artificial variable column that is eliminated from the basis in the phase 1 from the table. So in the final table of the phase 1, we have to remove the artificial variables columns. And next step is apply the simplex method to the modified simplex table and obtained at the end of the phase 1 till an optimum basic feasible solution is obtained or till there is an indication of unbounded solution. So after that, finally, after modifying the simplex table from the phase 1, then we have to apply the simplex method. Then we have to solve. So when the basic feasible solution obtained or maybe unbounded cell, up to there we have to apply the simplex method. So this is the procedure for the two-phase simplex method. So thank you.